Today we're with Quentin, who has worked on LLVM for quite a long time and recently written a book about it. If you have any questions regarding LLVM, C++, and that stuff, we'll have that after we look at the book. But let's take first, a chance to have an introduction. Who is Quentin?
Thank you, Jen. So I'm Quentin. I've been working in compilers for about 20 years now, mostly on low-level backend compiler, meaning the piece of the compiler that does the glue between whatever the programmer writes and the hardware. So I've been doing that for silicon companies like STMicroelectronics, but also for, I guess, better known company like Apple, Google, Facebook. So running things on different kind of hardware, like a microcontroller for hard drives, CPUs in your desktop, GPUs in your Mac, GPUs even on your watch, ML accelerators in data centers, so all that stuff. And essentially, whatever you do in your day-to-day life to run something on a machine, chances are it needs to go through a backend compiler at some point. And that's why I am, essentially.
All right. Let's get started with the book. And so you just told me that there is a bit of a story to this title, especially like you meant the upper part here, right?
A little bit of exactly. So the first blue lines are essentially my work. So what you see in those lines is the first line is the C++ code that most people would write. And then the second line is what is produced by something like Clang. So this is the LLVM intermediate representation. And that's essentially where the work of the backend engineer starts. And what you see in the line below is another intermediate representation that is used in LLVM, which is the machine intermediate representation. And this one is target specific. So meaning that what you see on that line, so a bunch of variable with the percent sign, but the interesting part is the opcode, the add WRI. So this is an opcode that's specific to AR64, for instance. And then the next line is the assembly code that you would get with such representation after register allocation. So W0 is your register for your target. So again, we're talking about low-level stuff here, like you're tapping into the right registers and the right memory space and all that stuff. And then the last line, the hexadecimal sequence, is actually the encoding for the machine so that it can execute this addition. So it's I thought it was maybe not clever, but a nice touch that if you know what you're looking at, it's real. But if you don't know what this is, it just passes over your head and it's like, yeah, some stuff there.
Yeah, and it's actually also made it to the printed book, which I got yesterday. So one of the rare interviews where I actually do also have the printed version. The ebook has the advantage that it's not that heavy. So when we go,
well, the advantage is that you could use it to
more than 500 pages. So this is really going in depth with LLVM. So let's take a look at the ebook itself. Let me just scroll out a little bit for that. And then that is
just to comment on the size of the book, the
yes
reason it's so big is that so the main goal of that book is if you ever worked with LLVM, there's essentially two parts in LLVM. So it's kind of weird in a sense when you're not familiar with compilers, but when you look at a compiler like Clang, there is the front-end part that is responsible of taking your C++ code and producing this LLVM IR. And when you have the LLVM IR, that's when you are into the backend code. Now, actually, when you zoom into the backend, there's several parts in there, and there's a part that we call the middle end and a part that we call the backend. So it gets confusing because the backend has a backend. But anyway, so the bottom line is that the middle end is very well documented in LLVM. It's the LLVM area that is used pretty much everywhere, like pretty much every language is lower to LLVM area, and that part is very well documented, and you know how to write optimization and stuff like that. But the second part, the backend part, has very little documentation, and I in that book I have to document that part. Essentially, that's the main goal of the book, documenting the backend part of the backend. But it wouldn't be a real LLVM book if I didn't also talk about the middle end part. So there's actually a good chunk of the book that is about the LLVM IR part, because if you don't know the LLVM IR part, you actually cannot work on the backend part. So when you put all those things together, it's really like from right out in the front end all the way down to the assembly code, there's a lot of ground to cover.
Yeah, and LLVM is quite a big project, so let's see what the book covers. So the first chapter, it's like not very surprising. We're starting with basically what LLVM is and getting started, and all that is what you just talked about. The various also the infrastructure which LLVM runs on, like the build system. Nowadays, LLVM is built with Clang, and maybe let's just have a look at that whole chapter a bit. So this is just the tools LLVM uses, right? There's Git, there's C++, of course.
Exactly, yes.
CMake, Ninja, and Python.
Project. So you need all those tools. Correct. Yeah.
And then basically LLVM is mostly implemented in C++ as far as I know.
That's correct. Yes.
Can you tell me something about what C++ standard does LLVM use?
So that's a good question. I don't remember if we are still on C++ 17 or if we switched to C++ 20. Essentially, we bumped the LLVM. So that one of the nice things about the LLVM code base is that the community tries to keep it fresh and adopt new language features to make sure that whenever there's new people that want to enter into the project, that can use whatever is the most advanced feature, as opposed to having to restrain themselves with, I guess, things that are maybe not so well taught in school and stuff like that. So that's not like a free thing, as in every time we bump the C++ version, that means that there are some toolchain that we won't support anymore. Like you need to bump your Visual Studio compiler that is supported by LLVM, Clang, and all that stuff. So we need to make a conscious decision that when we bump the standard version that we use, it may potentially push out some developers from the project, but also allow new developers to come in.
Yeah, that's like the second chapter is already then, so first is basically what setup you need, and then in the book, you're directly focusing on actually getting folks up to speed to contribute to LLVM.
Absolutely. So one of essentially the first chapter is about like how do you get your environment set up so that you know how to build LLVM essentially, and then down the road being able to modify it. And the second chapter is about something that, so I guess let me step back a little bit to give a little bit more context on the book itself. So I I've been working at Apple, Google, and Meta, and I've been onboarding a lot of new hire on LLVM. And essentially, that book is also the synthesis of these tens of years of experience with onboarding people, and I'm trying to address the questions that came often. And one of them is, okay, I know how to build LLVM and do things with LLVM, but how do I give back to the community, or how do I be part of the community? And what I wanted to highlight in the second chapter is that contributing to an open source project, and that's not specific to LLVM, is more than just writing code. You can help by reporting issues, you can help by helping reviewing patches, benchmarking things, participating in design discussion and all that stuff. And I'm covering essentially those things, and also ultimately contributing code, so that essentially people feel more familiar about, okay, how do I get started, and it feels like less scary in a sense. Like you have to remember that every contributor in LLVM or any open source project was an outsider at some point, me included.
Yeah.
So what I'm saying is that with enough time, that can be you. You could be the next key contributor in LLVM. I'm not saying I'm a key contributor, but I'm saying it's possible to get there.
Yeah, I think that's definitely something which we want to have, and we need more implementers for our infrastructure generally, be it LLVM, be it Clang itself, be it other projects.
Absolutely, and I think there's one of the mistakes that a lot of people make when they think that contributing to open source is about patches, is that for a community to work well, is that you need actually more people that review patches than people that produce patches. So if you have a big imbalance with respect to who's contributing versus who is reviewing, either your code quality is going to go down, or there's a huge bottleneck on the reviewing, and then your project is kind of moving at a slow pace. So what I'm saying is that reviewing is super important.
Yeah. And then you continue in chapter 3 about compiler basics and how they map to LLVM APIs.
Correct. So that chapter is really about giving you the fundamentals about how to get started with a backend compiler. Things like what is a control flow graph, what is a basic block. So if you've never worked on a compiler, those terms may not be familiar to you, and essentially I'm covering that in that chapter. So it's very down to the earth type of explanation. I'm not talking about mathematic formulation like that. There's a lot of books on that, and they do a better job than I do for those things. But I also feel that they are kind of hard to grasp when you're coming from I would say more practical background. So what I'm saying is that it's probably not the best scientific definitions that you would find out there, but it's probably the most useful one, if I may say. So here we talk about targets. So what is your target, your host? What does it mean to lower something? What is a module, a basic block, and all that thing. So essentially all the concepts that you will see that translate into C++ classes when you work with LLVM. And I felt it was important to introduce them so that you know when you're, for instance, working with the function class, you know what type of object you're dealing with.
And then you continue with basically starting on optimizations.
Yeah.
Chapter 4.
That's why it gets interesting. So the 3 first chapter are, would say, more ease into going into LLVM, and then the 4th chapter is really about, okay, now you kind of know the basis. Let's put that into practice, and let's try to write your first optimization. So that's why I introduce more of the APIs that are used to write an optimization, but also some of the concepts that are specific to optimization, like what is what is legal, like when you look from a C++ semantic, for instance, things, is it okay to replace a multiplication from floating point by like a different operation, or like a power operation with a multiplication, or things like that. So things that would make your architectures or your program in the end go faster, but that you need to make sure that you preserve the semantic of the input program.
That's true.
So yeah, because it's easy to have things go fast, but also to break the semantic of the program, and at this point it's kind of pointless.
So this was chapter 4. Now we go into like things which are now, I think now we dive more into the world of LLVM, right? With path managers. What's the path manager?
So path manager, the way LLVM is structured is a very modular compiler. The idea is that every optimization that you do can be actually be extracted in its own library. So there's when you think about the compiler pipeline to go all the way down to assembly, it's essentially a sequence of optimization that you put next to each other. And what the path manager is responsible for is making sure that that sequence of optimization, well, first of all, build that sequence of optimization based on whatever requirement you have. For instance, when you compile your program with O0, the sequence of optimization is not going to be the same as if you compile with O3. There's different things that you do, like, for instance, auto vectorization and this kind of things wouldn't be part of the O0 pipeline. So that is the first responsibility of the path manager. And the second responsibility of the path manager is that each of those optimizations uses some utilities that are provided by LLVM, and those utilities like compute some property about the program that you're transforming. And the path manager maintains this information on the side and make sure it's recomputed dynamically when you need it for your path, if it's invalidated by another path and things like that. So essentially, it's doing all the heavy lifting of making sure that whatever you see in your optimization is fresh, and making sure that your optimization is running when you say you wanted it to run.
Okay. Let me go back in the index. Then we go really deep with TableGen, right? Chapter 6.
TableGen. Yeah, TableGen is an interesting one. So TableGen, it comes from Table Generation, and essentially this is a domain-specific language that has been introduced in LLVM that we use to describe some properties about the target or about different things in the compiler. So, for instance, all the options that you see in Clang are described in TableGen, as opposed to writing a bunch of boilerplate code for all the command line options. We have a declarative DSL to map all those options directly. It's yet another thing to learn when you work with LLVM, but it's a kind of necessary evil because it is much denser than C++ in that front. Now, the thing that gets tricky is that TableGen is a language like C++, but then there's the way the language is interpreted depends on what you do with it. And in particular, the same DSL is used for like your command line option description, but also to describe all the intrinsics that you can see in C++. So meaning this really target specific low-level function calls that you would insert in your C++ program to use really specialized instruction of your architecture. So all that stuff is actually represented in the same DSL. And as you would expect, the way you interpret your TableGen description for your command line option is completely different of how you interpret your intrinsics definition. And I'm essentially trying to explain those differences in that chapter, and also how to approach a specific description in TableGen when you haven't seen it ever. Like, essentially, how do you find the information that tells you how to use that specific thing? So that's kind of a sore point for a lot of developers. So it's a very important chapter. I don't know how good of a job I made, because it hasn't landed in the reader's hand yet. But I'm hoping it will help clear a lot of the difficulties around that ESM, at least.
Yeah. So let's look at the next chapter for the book. And we've seen the chapter 6, and now we go into the second part of the book, where we now actually dive deeper into LLVR. And now we learn a bit about the AR. So that should be around 200. There we are. So we probably, this is a really important chapter, I think, which we have reached now. Now people need to understand that there is an intermediate representation. I think that's what's IR standing for, right? If I remember that correctly.
Exactly. Correct. Yes. Yeah.
So
this is essentially what all the front end that use LLVM produces. So Clang produce LLVM IR, Rust produce LLVM IR, Swift produce LLVM IR, and then you can look at other stuff like MLIR. So I guess so some ML related stuff produce LLVM IR. So essentially everything that wants to use LLVM as a backend needs to produce LLVM IR. So it's kind of this funnel that is common across a bunch of different languages and type of applications, and that is the archstone of LLVM infrastructure. It's really how you enter, in a way, into the LLVM ecosystem. And that chapter is about understanding how this IR is structured and how you manipulate it, essentially.
Yeah. I quickly had to post the link to the book. So this is a book which is especially about LLVM and code generation, specifically about the inner workings, which we now have reached, basically. The first chapters give you an overview how to get started and are more general, and gets people some knowledge which is not necessarily only needed for building LLVM, but also is, like, of course, using LLVM as an example. But if we look now at the next chapters, the second part of the book is now we've been here. Now we go into chapter 8 with survey of existing passes. Now we basically get a bit of learning about the infrastructure of LLVM, if I see this right?
That's correct, yeah. Essentially what exists there so that you don't have to re-implement it. Like, here is the power that LLVM gives you, and instead of re-implementing stuff, here's how you use it. And the idea of this chapter is really to give you an overview of everything that's available for the middleman. So again, the LLVM intermediate representation to LLVM intermediate representation transformations. And we go through all those things, and I give some tips on how you find the different optimizations that are available, and how essentially what they do with small examples, so that you can decide when you build your own own pipeline of optimization, which one you may want to use. So LLVM comes with a predefined default pipeline for optimizing or lowering, I guess, code with like a different pipeline for, again, O0 versus O3, for instance. But that chapter gives you some ideas how the type of things that happen and how you can tweak that things and by inserting whatever you want.
And then target-specific constructs is in the introduction in the next chapter, which...
Correct, yeah. So that's where we start to talk about things like intrinsics, like how you expose intrinsic in C++, for instance. So those magic function that will allow you to tap right into the power of your architecture from the C++ level. So of course you can use inline assembly for the purist, I guess, but intrinsic are kind of in the middle where at least you give some knowledge to the compiler of what's happening here. So that chapter covers this type of things, like again, intrinsics, but also things that are specific to the architecture, like how pointers are aligned, like what size of the address, like is it a 32-bit address space, is it a 64-bit address space? So things that are important when you do pointer arithmetic in your C++ program. LLVM needs to know about those things to be able to do the right thing. And being able to prove some things one way or another. Again, this notion of is it legal to transform my program one way or another to make it run super fast, and we need a bunch of information on the targets itself to know what you can or cannot do. And that chapter covers all this information.
Yeah. Then we jumped ahead of it, but the next chapter, the chapter 10, is hands-on debugging with LLVM IR passes.
Yeah, so that one is really about, okay, now you kind of start to know how to work with LLVM. Let's say that a lot of people don't know how to use a debugger. So the idea was in that chapter, here are the tools that you can use to debug your passes. So LLVM comes with a bunch of logging mechanism that you can use to like see the intermediate representation after like seeing the lowering pipeline. So the intermediate representation after different optimization phases. So you can see if the intermediate representation lowers the way you want, I would say. But also in that chapter, I also cover like the basics for how you debug LLVM with a debugger, like which functions in the LLVM API that you can call from the debugger to kind of inspect the state of the compiler. So all in all, that chapter is really about tips and tricks of understanding what's happening under the hood.
Yeah.
And of course,
so
instrument your code.
And I guess like when you work on compiler infrastructure, that is really important that you're able to use the debugger which comes with your compiler, and especially to understand its features to show you the IR and other states.
Yeah. Absolutely, yes. Yeah.
And
but for instance, if you see just this one command line, that's a tool that's super important as a compiler backend engineer. That one command line, for instance, allows to extract a specific piece of your program into a smaller file, so that when you try to reproduce a problem with the compiler, you can just look at this one small function as opposed to like your gigantic C++ file. So in that case, like we extract two functions, bar and foo, and put that in so from the input.ll file, which is the extension file for LLVM intermediate representation, and we print that on the standard output.
Let's look at the next chapter. We were at 10, now we're going and getting started with the backend.
So that's
this is now
where
basically
we get into the backend of the backend.
Yes, we are now really, really deep inside the compiling mechanism, right? So we are leaving behind everything that has to do with C++. This is still implemented in C++, but let me guess the number, 345. Yeah, here we are, getting started with the backend. And so now the backend is basically what produces the output for the assembler, right?
Correct. Yeah.
And
so the backend part is responsible for taking the LLVM IR that has been optimized by the middle end and then produce the assembly code. And that part in LLVM actually used a different intermediate representation that is called the machine IR. And it's really target specific at this point, meaning that all the opcodes that you will see, so what is it? The elemental operation that you can use in a way are specific to your architecture. So if I compile for x86, I would get different opcodes than if I compile for AR64, for instance. And that in that sense, so that intermediate representation is target specific, but what this chapter explains is that there are still like an overall structure that is the same for all the targets, and what changes essentially how the register file are described and the opcodes and stuff like that.
As this graphic shows, basically the backend starts when we have transformed the C++ from the front end into the intermediate representation, which is a blown up language inside of Clang, or like just a format to represent what the C++ code like would mean. And then now it gets in the backend, which has like the middle end, or like the pre-step before we then actually have the instruction selection, which then goes into the machine representation and then the assembler. And I think this shows very good here in this graphic. And then
so LLVM has a nice way. Yeah, so this is specific to LLVM. That's the serialization format for the machine IR, and it's kind of YAML based. If people are familiar with the YAML format. But yeah, essentially here I'm explaining how you read that stuff and how you interpret it and how you can play with it to even when you want to reproduce bugs and or test some things.
Okay, and now I see Nick, doing stuff like mapping the mir file to the C++ API. But now we're really deep into the basically this is stuff you work on when you want to write a new backend, a new module for LLVM, which translates to like a new assembler or a new machine platform when you have like an embedded device where you want to run your code on now.
Absolutely.
And I think that's one of the things you worked on. You said on the beginning that for various companies.
Absolutely.
And then chapter 12, we're going into the getting started with the machine code layer.
So the machine code layer is yet another intermediate representation in LLVM that is used at the very end of the pipeline. It's essentially the abstraction that hold all the information about the encodings of your target. So, encodings and assembly. So, meaning how you print your strings for your C++ toolchain for the assembler for this particular target, and how you each instruction is encoded in binary format in the end, and the binary format also depends on the OS. Like the way the binary file is structured is different if you run on Windows or if you run on Linux or if you run on Mac OS or iOS and stuff like that. So here I introduce all that because that impacts the way you model your architecture in LLVM. So again, very low level stuff. It's not related to C++. At this point, you're getting really.
This is not really in-depth stuff.
Here is how my target works.
The machine pass pipeline. We're now like really deep inside the compiler, where normal folks will never go. And chapter 13, the machine pass pipeline. Now we have basically the representation, and where does this pipeline go?
So that pipeline. So again, the pipeline is the sequence of optimization that you run for your in your compiler, and specifically the machine pass pipeline is there is an example here. Is what are the different optimizations that the backend goes through to get all the way to assembly, and to I guess make it kind of high level. The idea is that LLVM uses an intermediate representation called static single assignment. So that's something that you don't need to know how it works, but essentially that's a way to represent the program that make it more amendable to optimization. It's easier to prove things on that representation, but that representation comes with, I would say, quirks that are incompatible with hardware constraints. So you have to get rid of that. Of that representation, and that's what the machine pass pipeline does. It's putting it really in the linear sequence of code that you wouldn't see when you print your assembly code, and also assign the registers to all your variables. Like when you're writing C++, I'm hoping that you're not worrying about how many registers you're using and things like that. Well, you could, but hopefully you're not optimizing on the register allocation by hand, and that's what this pass does. It's okay. Here are that many variables are used, and you put them in registers and stuff like that. And that at the end produces your assembly code.
And that brings us to the fourth part of the book, which then is actually about the final part of the journey of the becoming assembler from the compiler, right?
No, actually, so that part is a little bit tricky. As in, like, if you remember, there is the middle end, then there's the backend, and in the middle there is this thing that is called instruction selection, which is the thing that's responsible for taking the LLVM IR, which is somewhat target agnostic, and translating it into machine IR. So the reason that I cover that, I guess, later is that piece is kind of the heart of the backend, and it wouldn't have made sense to talk about it before we explain all the subtlety of the machine IR, because essentially you are, as a backend engineer, you have to produce the machine IR yourself from the LLVM
of these parts. So you're getting started here again with introduction selection in chapter 14.
Exactly.
And then you go deeper into introduction.
Just the getting started. Yeah. So essentially, again, this is really the beating heart of the backend, and that part is so complex that it's actually broken down in different phases. So it's still part of the same optimization per se, but there's different phases. And for instance, if you look at chapter 16, the legalization phase, like think about your C++ program when you do A times B, for instance, it's possible that actually let's say you're using double precision floating point, and when you do A times B, it's actually possible that the processor that you're running on doesn't support double precision arithmetic. So the responsibility of the legalization phase is, okay, the program wants to do this multiplication for a type that I don't know how to do. How do I make sure that it's still possible to run on my target? And that's where things like call to libm or things like that will be automatically inserted, or clearer things where, it's like you're doing a power, and we know that in that case, it's okay to replace power by a multiplication if you support that. So, but there's a bunch of things that you need to do to essentially take whatever crazy thing as a developer you can write and make it map on the actual hardware. The hardware is much more constrained than whatever C++ exposed to you.
And then the book goes in its fifth part into the final lowering and optimization.
Yeah. So that I would say,
it's the 18th chapter.
Yeah. So those are more, I would say, it's mandatory steps in your lowering phase, because like you have to produce a linear sequence of instructions to produce your assembly. So you have to schedule the instructions. And you have to, then chapter 19, register allocation, you have to allocate your register, otherwise the hardware will have no idea how to pull the variables and all that stuff. And same thing with chapter 20, you have to lay out the stack.
Right. And
exactly.
Chapter 20.
So all those things come.
The stack layout.
Yeah. So all those things come pre-existing in LLVM, but you still have to configure it to do the right thing for your target. So that's what I'm explaining in those chapters. And then chapter 21 is really like just the cherry on top. Like if you're not content with producing assembly strings, I teach you how to actually produce the binary code. So it's very lightweight in the sense that it's only showing the ropes, because you could write a whole book about binary tools. And like you saw, Jen, the book is quite big already.
Yeah. It covers the whole journey, which is nice.
Absolutely.
So
yes.
let me go to the first page, and we are now through with the overview on the book. And so let's get started with the interview. A lot of people already have done this, and let me quickly see if there's like already there's a ton of questions. And so
okay.
I do also have like some questions prepared, but let's see what questions from the audience I can show you. So we're starting with a question from Andre Tsisou. If I want to gain enough knowledge, not necessarily to become a contributor to LLVM, but just to be able to experiment with implementing new language features I may have in mind, so they are a committee member. Will this book give me the required jumpstart? Also, to what extent is the book useful for people without prior compiler background?
So for the first question, like if the book will help you with language features, I think there's two aspects here. It's like how much of the language feature are actually impacting the C++ syntax itself, and how much of it is pure backend. Like let's say you're adding a pragma that allows you to do some security check or whatever. That part will be wired up automatically by the existing front end. And then indeed the book can give you the ropes to essentially then implement that feature in the backend. Now, if your language feature needs to modify the front end, like for instance, when auto was introduced, and then where you need to have some type inference and stuff like that, the book is not going to help you at all. I do not cover the front end part at all. It's really a different world, and that's not my jam. Let's put it this way. Now, with respect to the second part of the question, like would that book will be useful for people without compiler background? I would say absolutely. That's why chapter 3 and 4 are here, to give you the concepts that you need to work in the backend. But again, those concepts are for compiler backend. Like, it's not going to talk about abstract syntax tree and making sure your semantic is correct and your type inference is correct. All that is not covered by the book. So compiler background, yes, but compiler backend background.
Yeah, so I think that's an important distinction which we should make, is that the book is not like specific about Clang and C++ implementation, but more about what follows when the translation happens from that to LLVM and its internals. So if you're working on language-specific features, then the book will help you to understand what these gets translated in and be like LLVM-specific details. Let me see the next question. So Nicola Fogg asks, if I had a custom processor, would I be able to port Clang to that processor given the information in this book? Is there a hands-on exercise for porting LLVM to a new processor?
So absolutely, that's kind of the point of the book, to give you all the information you need to build a custom process or custom backend. So I would say, depending on what you mean by custom processor, you need to be careful, as in there are some information that usually are given to you by the architect of your processors, like things like what are the instructions that are supported by your processor. So if you're trying to build yourself your custom processor, you have to think about what are the instructions I want to support to be able to implement them in the backend. But separate discussion. So short answer is yes, that is what you need here. And with respect to, is there an hands-on exercise for porting LLVM to a new processor? Absolutely. And actually, the book comes with a GitHub repository where I step by step commit a new backend. I show you from doing nothing to having your backend being connected to Clang, to how you can produce assembly from C++ to your new custom processor. So just to set the expectation, it's a toy processor, so it doesn't do fancy things, but at least it gives you the idea of how you plug the different things so that it works end to end.
But yeah, that's my impression from the book, is also that it definitely will help you to get started with, getting a feel what you need to do for doing this. And then, I mean, we saw that the book is already quite in-depth, but like going like into custom processors and even more in-depth, and you have a very specialized book.
Yeah, absolutely. I would say the idea of the book is show you how things works so that you can go beyond what's in the book.
And then a bit of a simpler question. It's like, LLVM is a compiler. Why do you have to run Clang, and LLVM can work even without Clang? Or so they are tied to each other. Let's go with that.
Yeah. So there is actually something called LLC, so the LLVM compiler. So you can actually run the compiler without Clang. But here's the catch, is that LLC is about compiling from LLVM IR to assembly. So if you want to program in LLVM IR, be my guest. But I would think that you would prefer to program with a higher level language, and that's what Clang++ does. Is essentially your companion to produce the LLVM IR that represents your C++ program. So again, this notion of front-end versus back-end. And when we look at Clang, it's actually more than a front-end, it's actually a driver. And under the hood, it called the preprocessor, and then it called the actual parser and all that stuff to do the C++ lowering to your LLVM IR. And then it calls the LLVM compiler. And then depending on what you want as output, like if you want an object file or if you want assembly file, it may even call the assembler for you. So Clang is really a driver that allows to stitch all the pieces of LLVM together so that you don't have to do it by hand.
So the book has like build instructions, but are you also familiar, or is the book helping you with building Clang under Windows?
No. So I know that in the book I point to the official documentation where I think they cover Windows, but I didn't have a Windows machine myself to test things. So everything that you see in the book has been tested by me. So I know it works. And since I didn't have Windows, I didn't put anything on Windows. So it's in that sense, it's uncharted territory, but it should work.
Mm-hmm. And I see there's a follow-up question from Nikolai. In addition to my previous question, so I see that there is a book like Learn LLVM 17 2nd edition. Which book would be the best to read if you wanted to add a new CPU architecture to as a backend?
Yeah. So if you want to add a new CPU architecture, I would say my book is much better because if you look at the LLVM 17 book, the backend part, and it's true for pretty much all LLVM book out there, there's no book that covers the backend part. So everything that you saw, so first of all, the TableGen part, which is an important tool in LLVM, is not covered from what I remember. But more importantly, all the thing about the machine IR, register allocation, instruction scheduling, encoding, and all that stuff are not covered in those books. Those books are, I would say, focused on the, in a sense, what makes LLVM, which is really the middle end. And my book is really about the backend of the backend, if you want. Also, just for what it's worth, the book is based on LLVM tuning.
So, someone asked, does this book cover MLIR and what?
No. So I don't know of a book that covers MLIR. So for instance, I actually work on LLVM for the past 3 years. I wanted to cover it, but the book was too big already, so I did shed it. But essentially, MLIR is another intermediate representation that sits on top of LLVM IR. So in that sense, you could kind of say it's a front end. The reality is that it's more type of a middle end, but yeah, I do not cover that at all in that book.
Okay.
And yeah, I don't have any recommendations, sadly.
And then there's, of course, the question like, would you recommend any complementary book focusing on the front end?
Yeah, no, I cannot make any recommendation there. It's kind of, I kind of feel embarrassed that I have to admit that everything that is above LLVM IR is kind of syntactic sugar for me, so I'm not super into that type of thing. So I kind of am oblivious to all that stuff. So sorry, I cannot give you good recommendations there.
All right, so there's a question which didn't show up here, so I copied it, and it shows now up here. So you seem to be at least a contributor to GlobalISel, which, we probably first need to translate this question to the audience, right? What are these?
Yeah.
And I quickly checked that this is something which is in LLVM, so that question makes sense. So
yes. So ISL stands for instruction selection, and Global is the framework. So instruction selection, there's different frameworks in LLVM to do instruction selection, and I cover that in the first chapter, like getting started in the first chapter on instruction selection. Like the getting started with instruction selection covers the differences between the different instruction selection frameworks. So I would say there's not one major. Well, there's several differences. The major one is the global part of the instruction selection. So the global instruction selection is global to the function, meaning that when you're lowering your code from LLVM IR to machine IR, you have a view of the whole function at a time. So meaning that you can make decision of the instruction that you want to use based on the full context of the function. Whereas when you look at selection DAG has a much narrower view, where to put it in C++ term, you essentially see one block of your function, like what you have between two curly braces. So that means that you have much less context to decide what type of instruction you want to use, and it also limits the type of optimization that you can do, because if like when you have your variable that is produced in a statement, and then if it's used in a different block, you may not see how it has been produced in selection DAG. So that means that there are certain optimization that you may not be able to do. So in that, I would say the major difference again for GlobalISL is the scope that you see, and that means that you can do clever optimization. Then there's a bunch of other differences. I would say two of the big ones are GlobalISL is purely written in machine IR, so using just the machine IR. Whereas selection DAG has its own also intermediate representation, and that has two impacts. The first one is that selection DAG is slower in terms of compile time. It's yet another IR translation that you have to do in your compiler pipeline. So that means that the user of the compiler will spend more time waiting for the compiler to do his work. And the second thing is that since selection DAG uses its own intermediate representation, you cannot actually pair it with a generic optimization that you can do in GlobalISL. I'm not recommending that at all, but for instance, in GlobalISL, you could put your instruction scheduler between the legalization phase and the selection phase or something like that. So what I'm saying is that GlobalISL is much more flexible, it's more modern, and that means it's easier to develop and debug. And when you put all things together, so better scope, better compile time, and better flexibility. And yeah, I'm a major contributor of GlobalISL because I haven't did it, so I'm kind of biased in my answer.
So this is basically a question which I just come to my mind. You know, compile times are such a big issue for C++. How much work does LLVM do in parallel?
So sadly, very little. So one of the problems is that, and it's like a problem that the community is very well aware of. So one of the problems is that LLVM relies on the type uniquing mechanism that is relied on when you're doing optimization. Like when you're checking if, for instance, two variables are using the same type, you do that by just checking if the pointers are the same. So the underlying C++ object is the same. So now if you start to having things that runs in parallel, that means that those types may be created by different threads, and they could be some race condition and all that. That makes that the type uniquing is pretty much broken at this point, and then optimization will go not where you want. So I guess long story short, the parallelization work in LLVM is pretty much inexistent at this point.
Okay.
Sadly.
So if you want to get started on that, that's a great book to get started on this journey. Let me see. I also have a few questions myself. So let's get basically back to the book, right? Something we haven't talked about at all. Like, what is the audience you had in mind when you wrote the book?
So the audience I had in mind were, I would say, two different kind of publics. So the first one is actually students started in compilers and wanted to really learn the how compiler internals works, and I mean really the backend part. So I guess to step back a little bit, when I learned compiler at school, we spent a lot of time about abstract syntax tree and all that stuff. Like how do you make sure that the language is typed properly? And personally, I found that very boring. So that book is actually covering what's happening after, which is how do you actually produce code for your actual processor, which may or may not be covered in classes nowadays. But yeah, essentially it was okay for compiler enthusiasts that are interested into getting into backend world and see how things works under the hood. And the second audience was people that may already know this type of world but never worked with LLVM. So I wanted to break it down how things work in LLVM and how you use the LLVM tool to really get started and then either contribute to existing backends or write your own. And again, what's in the book is based on what I saw people asking me over like the last 15 years or something like that.
Yeah. So basically, I see that basically your own teachings have led to this book. And so what did you learn about C++, but also about LLVM while writing this book?
So I wouldn't say I learned. So I would say I learned things about LLVM because when you have to explain things, when you work with LLVM, sometimes you make some assumptions, and when you have to explain things to people, you have to actually check that your assumptions are correct. So in that sense, I was able to confirm or deny some of my assumption and correct them and show them properly in the book. Like things, for instance, around how the encoding works so it's all based on TableGen, again this DSL, but there are so many indirections that it's kind of easy to get lost in translation per se. And I had really to sit down and it's like, okay, I've been doing that for years, but actually how does this connect in the backend? And it was kind of surprising to, even after working with LLVM for more than 10 years, to actually see, oh, okay, that's how it works. So that part was funny. With respect to C++ itself, I would say nothing in particular. I've just been using C++ a lot, and LLVM usage of C++ is pretty basic. Like there's no exception, no complicated. Well, there's a little bit of template method programming, but not so much. So all I would say the fancy C++ things are pretty much not there. So in that sense, the LLVM code base is huge, but the implementation in terms of C++ is actually pretty basic.
So you are saying there's room for improvement?
Yes and no. I like basic, let's put it this way.
All right. So
like for instance, one thing that's interesting in LLVM. Oh, sorry. I just wanted to learn one thing that's interesting in LLVM is that there's no RTTI, so no runtime type checking. And LLVM rolled out its own runtime type checking. Is actually everything is static and is based on enum and all that stuff. It's kind of an interesting pattern, but it's I would say it's a nice trick to see if you've never seen that in C++, but it's not like rocket science and whatnot.
And so this is a big book, and this just released actually. The first ebook which Pact sent me had like big printed on every page, packed internal, do not share this. And then I'm glad that, this is a big book, but you can't write such a big book without making errors. And this is a complicated topic, as you said, as you yourself learn like how things actually work when writing the book. So do you have any known errors in the book or things
I have one right now. It's a minor one. It's so each chapter. So the way the book is structured is that at the end of each chapter there's a quiz to see if you kind of understood what you read, or also the way I actually wrote it is that instead of reading the chapter, you can start with the quiz, and if you see that you can answer the quiz easily, then maybe you already know what's in the chapter, so you can move to the next one. So anyway, back to the errors in the first chapter. So it's kind of sad. It's like the first chapter and it has an error. In the answers of the quiz, one of the answer is badly labeled. So you think it's the next question, but it's actually the answer of the previous question. So be aware. So like you say, there's it's a big book, so there are errors. That's for sure.
All right. Then I guess if you have any more questions about the innards of LLVM and generally, but of course, I already have a feeling that there's like a few chapters which are potentially in there, as we talked about MLIR. So
correct. Yeah.
What didn't make it to the book?
There's actually a whole lot that didn't make it into the book. So that's kind of funny because I've been working on LLVM for almost 15 years now, and at first when I wrote the table of content for the editor, because you essentially have to make a plan of what you think you're gonna speak about, I was actually thinking that the book will be short. And as I was writing the table of content, there were more and more stuff that were piling on. And when I said, okay, that's fine, I can talk. Like, for instance, if you look at the chapter on register allocation, it tells you how to leverage the existing infrastructure to do your register allocation, so to assign those registers to your instructions. And I'm actually the code owner in LLVM for the register allocators, and I know how they work inside out, and it's not very well documented. So I wanted to use the book as an opportunity to really documenting very well how the algorithm work and what are the different phases and all that stuff. And actually, just writing about how to use it already, the chapter, I don't remember how many pages it is, but maybe 30 or 40 pages. And okay, it's probably already long enough. So I will not spend maybe the next 120 pages explaining how it actually works. So that's the type of things that it's kind of an interesting exercise, that as you do this introspection mechanism of, okay, what can I teach other people, you realize that you know much more than you thought. And there's like a small tricks and tips that are super useful that you wish you knew and you want to talk about it, and then you end up spending pages about explaining the context and how that works. So in the end, a lot of, I would say, gory details have been left out. So same thing on the instruction scheduling, same thing with GlobalISL and actually selection DAG. So like another example is in selection DAG, a lot of the things that you do are driven by the TableGen DSL, and that's the declarative language. Like when you see this type of IR produce this type of instruction, very simple. The thing is that what LLVM does is actually producing an automaton that runs through the IR and jumping back and forth, like if blah blah, many operands, blah blah blah. And the automaton is like a massive file of it's actually a big C++ table with a bunch of enums and bytes offset in the table and whatnot. And I wanted to explain how that thing works. And after just explaining how to write the DSL, the chapter was already too long. So I was, okay, if people want to know how it works internally, I guess that would be for the advanced LLVM Code Gen, or will just ping me, because it's just too long to document all that stuff.
All right. That, I think, brings us to the end. Thank you, Quentin, for your time. That's really an interesting book, and it's a very unique
for making it done.
And so if you're interested in working on LLVM, and if you're interested in, maybe having the job to port certain processors or new hardware to an LLVM backend, that is the book you want to read.
Thank you, James. And I would say, don't be shy. Feel free to reach out on LinkedIn, on Discord. Like LLVM has a public Discord server. I'm lurking there, so say hi. Happy to connect. And yeah, enjoy your backend journey. And again, thanks a lot, James, for making this meeting happen.
All right. Then I think I actually will take us offline. Thank you for your time, and